All right, so we shall start right now. And yes, so as an official introduction, yes, I'm the elusive lizard, just as elusive as the further math topic. And I'll basically be sharing my journey 3 years ago, that started 3 years ago and ended 2 years ago. Yes. So just as a start, as an introduction, so I wanted to take further math and chem, right, along with math and econs, right, if econs being the contrasting subject. But my school only offered further math and physics, which was not great because I can't do physics to save my life. As ironic as it sounds, because further math can do physics. Yeah, what a load of bull. But not for me. Generally, it's true. Uh, I'm just an anomaly, I guess. And well, I figured that if I could do further math, I want to do it with chem. And if I had to take physics, well, I'd like to just take it as the problem subject as I seen it back then. And that's why I offered, or rather selected, to do PCME and as my first choice. So before I actually want to start on my journey, you might want to check the available further math combinations offered by your interested schools, and as well as the conditions to take further math and the appeal processes, right, which I will share with you that I ended up did getting PCME, not my ideal choice. My second choice was further math and physics, which obviously that got rejected. And my appeal with further math and chem also got rejected. So what was my last resort, which was that second round of appeal, which was in hard copy. And that hard copy appeal was hilarious because I just basically, it was basically a plea to not do physics, as I attached all my poor physics results from Sec 3 all the way to Sec 4, and also attached my slightly better chemistry results from Sec 3 and all the way to Sec 4. So the file was about this thing. Yeah. Went from one piece of paper to that thickness. And I did end up taking further math and chem, right? My appeal went through. But it was only approved after I met with the math HOD. And that was a meeting that I will never forget. Not because of how hilarious it actually ended with, but because of this important question that I was asked. And it's also the same question that I would need to ask you, and more importantly, you need to ask yourself. The three famous words other than I love you is are you sure? Now, why I asked that? Now, if you actually caught a glimpse of the first animation, which I gladly skipped, FM was reintroduced in 2017. And now it's the seventh year, I think. Well, ironic, I can't do math now, but yeah. And it's a relatively new subject that still is quite difficult and very challenging, which is the reason why that you need to have a proper reason to take further math, and what are your plans that warrant you or that persuade you to take further math. That is the question, or rather the questions that you need to ask yourself. So some of you might have asked, is further math suitable for me? My question that I'm asking you is, are you suitable for further math? Right? It's not the other way around. Because further math is never suitable for anyone. Right? Any sane person shouldn't really take this challenge. But you must have very specific reasons to actually take it. All right. But let me just share with you some of the conditions which I think logically would warrant you to take this. At least give you the chance to take further math. How was your A math and E math? I remember attending the sample lesson, and the first thing that my tutor said was, to me, math being stable is about 90 plus for each A and E math paper, not just 80, not just 70. And to a certain extent, I agree. Because the idea of further math, the most fundamental ideas, rely on your mathematical knowledge and techniques. And this is derived from your A and E math, where that is the basic building blocks to not only H2 math, but also to further math. So are you fluent with those concepts? Are you able to create your own patterns? Do you understand them? All right. Now, that is giving you at least a chance to take further math. Now we talk about the hard admin stuff, right? Further math takes away one science subject for another math, right? So essentially you're taking two science subjects when taking further math, which can be a good thing, can be a bad thing, all right? If you notice, the basic combinations, PCM, BCM, chem computing, physics computing. But when it comes to further math, you only have three other science subjects to take: physics, chem, or computing. No bio at all, which is the reason why many courses are off the table. You want to be a doctor, you want to be a dentist, you can kiss those dreams goodbye. You want to study life science, you can also kiss that goodbye. And NUS, NTU, certain courses require two sciences when I talk about excluding math, that are also out of the option, right? And again, do your own research. I'm only listing NUS, NTU. Of course, look at the other universities as well, right? Before you consider taking further math. Back on suitability. I know I'm a very lame person. I chose this meme because you need to really have a good grasp of math in order to take further math, right? Back to the 90 plus or A and E math, because not only does further math require A math understanding, it requires H2 math understanding as well. And as mentioned in the previous webinar, the previous sharing, the jump from A math to H2 math is quite big. The jump from H2 math to further math is equally big, but in a different way, not in terms of concepts, but in terms of the questions tested. Further math also teaches us alternative methods that are highly applicable in H2 math, but of course, not for every subject, not for every topic, only specific question types. All right, so these are the few things that might spark your interest or might turn you off. And for one of the more lame reasons to actually take further math is the distinction rate, right? I'll touch on why you shouldn't really take further math because you think it's easy to get A. But let me give you some hard numbers first. Very high, right? Looking at the available data, right? When you talk about available data, apparently the only available data comes from the top schools: Hwa Chong, RI, RV, and EJC. The distinction rate, aka the A rate, is the lowest of all science subjects. All right. Again, looking at the same schools: chem, computing, physics, bio, worse, 60%. Further math at average, 50% at best. Okay, so that's the first reason why, if you want to take further math because you think, oh, it's easy to get A, you are wrong, right? And I'm sad to say that further math has one of the worst A rates for the science subjects. Well, it's not really my fault, but yeah. But again, further math, very small pool of people. If you have the skills and passion, which you should have before even taking further math, before even considering further math, it's likely that you'll get an A. But the journey to getting the A is difficult. All right. Again, any considerations? Passionate, the drive to learn. And it's not just rote memorization, just spamming the questions. Why? Because further math, the challenge of further math, as I'll explain later, is the unpredictability of further math. And are you willing to give up another science subject? Again, giving up another science subject, you remove many of your available options. Do you plan to take math, engineering, computer science, data science, statistics courses? You might have a head start by taking further math, right? But again, you don't need FM to take any of these courses, locally or even overseas. So if you prefer to take physics over math, go ahead, right? And I recommend you do so. Okay. Regarding overseas, I'm going to keep it very short. If your plan includes studying math overseas, then I highly recommend that you take further math, right? It will help you greatly. And H3, if you wish to, right? If you're really passionate, you can go do that H3. And the good thing about further math is you can decide whether or not you want to continue doing math. And if you do, you have a head start. If not, it's a good learning experience. You know what you want to do in the future, right? And just to share, one of my tutors, he admitted that I thought I liked math before I go uni. At the end, I realized after taking math in uni, I didn't like math after all. Right. So this period of time is also about figuring out what you like and what you don't like. And I'll elaborate on that again at the very end. Now, talk about the actual stuff for the math. It's another 2 papers, 3 hours each. So in if you look at it, uh, both math and further math, right? If you do take both, you're taking 4 papers, 3 hours. That's 12 hours of math. But of course, with enough practice and as you progress to J2 and you learn more of the skills and you get used to it, you realize that you can complete the papers slightly earlier. But then again, you need the rigor and you need the perseverance. So 12 hours, 4 papers. At least it's math, it's writing numbers, right? Compared to writing like, I don't know, 3,000 word essays or econs. So as I mentioned about the very small pool of people, there's no bell curve in further math. You are your own bell curve, right? Your performance will decide your grade, right? Directly. And you have limited external resources, right? There's not much available resources out there because further math was removed from the syllabus in 2004, a good 17 years ago. As such, you can only rely on your school's resources, which fortunately for you guys have increased because the first time it was reintroduced, it was in the year 2017. So they are, by the time you come to J2, they have 6 years worth of resources that you can use to hopefully ace your further math. And in some schools, which I believe might be all schools, would also require that every applicant for further math, if shortlisted, would require to take a selection test. Now, for my year, there was no selection test, which was fantastic. But from what I've gathered, they don't just test you on knowledge that you already know. They'll test you on knowledge not only in further math, but they test you on how you can think, how you can adapt, and how you can apply, right? These 3 skills are the main 3 skills that you need to ace your further math. So there are 4 main skills that you will develop in further math: critical thinking, adapting to the context, analyzing the context, and last but not least, experimentation with your fundamental ideas. On top of it, you need these 4 skills to tackle the novelty in further math. Further math, the main problem in further math is this novelty. And with that, you need to present your knowledge and showcase your techniques, right? Now, one question is, how do I understand ideas, right? Let me tell you how. There's a big difference between learning the techniques, knowing it, and understanding it. Knowing the technique is knowing how it works and when to apply, right? That's it, right? They give you a fixed context, they tell you, okay, it's like this, right? It's like instructions, set of instructions. Understanding it means able to come up with your own way of thinking, customized way of understanding it, and asking yourself these 2 questions. How it might work here, and how can you apply here? And this also ties in with the idea of experimentation. If it does not work here and it can't be applied here, then you go back again. What other methods are possible? And then you try to do it again, all right? If you can apply it in a normal situation, it just simply shows that you understand that method, that idea, that technique, that context completely. Another question, which I believe some of you might have asked in the previous sharing. Math versus further math, all right? Now, I would like to give a disclaimer. I'll be referring to H2 math as H2 and further math as FM, all right? So this is a habit that I kind of developed. So please bear with me when I talk about H2 is H2 math, further math is further math, or FM is further math. Now, in H2, looking at the content, right? So H2, well, I use the Venn diagram, which I'm pretty sure you guys would encounter in PNC in year 2. So on the left, we have math. On the right, we have FM. Math, H2, are the stepping stones for further math, right? They introduce to you the very basic ideas of certain new topics, such as complex numbers, such as differential equations. In further math, it is an extension. And this extension, and some jokes we call it, how further is further math, is quite further. All right, you notice that in extension, there's not much overlap between further math and math. Right? This extension, some contexts are exclusive to further math, some contexts are exclusive to math. Math teaches you basics, right? Just simple introduction of the ideas and some techniques that you still need in further math. But the methods you learn in further math, some of it you can be used in math. Most of it is exclusive to further math. All right, so in essence, it's still 2 subjects, but I say it's something like about 1.5 subjects in place of 2, right? And I'll elaborate on that again later on. Now, 3 main things in H2 and further math: technique and skills, creativity and freedom of expression, and novelty. In terms of the first one, technique and skills, both math and further math test technique and skills. All right, math teaches you need to know how to at least differentiate in math. You need to know at least how to differentiate in further math as well. But in terms of H2 versus further math, creativity in H2 is not much required. All right, it's a very low 3. Because in math, there's at least still some classical types of questions that are still categorized. And you can actually match the method or the whole idea to it. So in essence, math is grindable. H2 math is grindable. But in further math, you are given this creativity and given this freedom to express math in any way. Ultimately, math is math. And they are basically giving you this freedom, requiring you to use that freedom to be able to show that you have the understanding and essentially solve the novel questions, right? So with great freedom comes great responsibility. Lastly, in terms of novelty, I won't say that math have no novelty. You will still get different contexts, but the contexts are used in a more predictable kind of way, right? You can kind of like find these very standardized questions, standardized methods, standardized ideas that, oh, let's say in differential equations, you know what to do already, right? It's just this, and that. In further math, that is the main thing that they are challenging you. It's as good as a 10. There are no specific question types, unlike in math. There are no predicting in further math because they can throw you a new context and expect you to use the same method. But you will never, or you're unlikely to use that method before in those types of contexts or in similar types of contexts. So in essence, further math tests on these 3 things: technique and skills, and your creativity to deal with the high degree of variability in the novelty. In math, it tests you on technique and skills and just basic understanding and seeding of information. In terms of content, math has 10 pure topics, further math has 7 pure topics. First topic, they are quite common really, sequences and series. On the other hand, we have further math with recurrence relations, right? Now, why I underline the recurrence relations? Because in recurrence relations, you get to learn one method that is incredibly useful for your H2 math sequences and series. Then in further math, you learn mathematical induction, which is the sample lesson that I'll be giving later on. In math, graph and transformations, further math, conics, and polar curves, right? Bolded because it is a difficult topic, right? The context for polar curves, for conics, is simply incredible, right? You learn a lot of things because you make a lot of mistakes as well. Math, integration, calculus, right? Integration, differential equations, differentiation. Those are the same things that you learn in further math. Definite integrals, differential equations. And then the rest are the rest. One more thing for further math. This idea of vector spaces, aka the dreaded linear algebra. Now, this really depends on who your tutors are and how they teach this subject, because it can be quite confusing to learn if you don't understand it very well. All right, don't understand the idea behind it, and you just simply try to memorize or spot patterns, it doesn't really work. All right, for linear algebra, it's very abstract, but it's not that difficult, although the context can be as wild as as it goes. All right. Stats, I think, is the most simplest part of both math and further math, excluding probability and combinations in math. That one is also a different kind of hell. But in further math, you learn a lot more new tests and you get to understand some of the new ideas that people have come up with and the different contexts that they can be used in, right? It's actually quite incredible. Personally, I've conducted my own hypothesis testing because of further math, okay? So back to considerations. Now, I'm not telling you that you need to know what you want to do now in uni, all right? Because, you're still 16, 15, you're not required to know what you actually should do now or actually want to do now, right? You're still in the stage where you're still gauging your interest and assessing what you really want to do. But at least, have some sort of a skeletal plan, know what are your available options, what kind of combinations that you would like to have, and then pick the one that gives you the best options or the most optimal options that you like. But just a caveat, further math reduces your choices, as mentioned earlier, but you still have a variety, but it's a limited type of variety. And you should also consider whether you are passionate to do further math. Are you willing to take this journey and come out stronger as a mathematician and as a person? All right. Now, I believe a handful of you have already settled with further math, just like I was back in Sec 4 when I was still dumb and ugly. And you also plan to do math, all right? Then the next question that I was asked at the meeting is, what's your backup plan? I shared with you my tutor of not liking math after doing math in uni. So let me ask you, if you take further math and then you realize that it's not your cup of tea anymore, what do you want to do? Right? Now, further math has no H1, right? There's no such thing as H1 further math, right? That is not a thing. Neither is there H3 further math, right? So once you take further math, you're stuck with it forever. So that's also another consideration that you need to think of as well. So let me share with you my journey as quickly as possible. All right. But before that, 2 questions. Learn independently. Are you able to learn independently? Do you like to learn independently? And next up, this is how your journey would look like. From year 1 to year 2, you have 5 major exams, right? Block test 1, promos, then J2 block test 2, prelims and A's. So these are the 5 major exams that you have. And the first few exams, it will be an eye-opener, right? So my journey, a bit different back then when there was still block test 2 for J2. So I had sort of 5 major exams before A's. First part, very smooth sailing, right? I understand everything. Ooh, fantastic. For the math, easy. Come to block test 1, I scored a very good grade of 52 out of 100. It was an E grade. And that was when I realized that there's a difference between learning and understanding. You can learn the method. Can you apply them properly? Are you able to deal with the new context? So that is a challenge. But the main important thing is, even though it's got this new grade, never beat yourself up. Never lose that passion for math, right? You can always, come back with a greater grade. But not only that, the idea of enjoying studying, enjoying further math, enjoying the challenge that's presented, even though I lost at every battle. Every battle lost gives you great insights on the opponent, and the opponent is further math. Moving on to promos, along the way, learn more mistakes, was taught the incredible idea of linear algebra. That was scary though. And I remember 2 weeks before promos, my common test, I scored only 13 out of 30 for my linear algebra test. So it was a great confidence booster. Came to promos, again, keep an open mind, just go in, you have one job only, do your best, do math. Yeah, it's just doing math. And that's why I said that you need to have the passion for further math, right? Because you need to enjoy yourself during the examinations and during the paper. And I got an a borderline A, 70, even though I got 2 questions wrong at the very start. I got the first 2 questions wrong. So again, there are things to celebrate and things to take note of, right? Things to celebrate is that significant improvement, right? Not just in terms of the grade from 52 to 70, but also some consolation that I have some subjects or some topics locked in. All right, definite integrals, conics, okay, not really conics, definite integrals, numerical methods, and of course the rest just needs more improvement and needs some refinement, which again is not a matter, right? An A is an A. I'll take it. I'm satisfied. But we need to keep moving on, right? You need to keep improving and keep learning. Came to December, again, I think your schools will also give you some end of year practices that you can use, and you should do them over the holidays. It's a really good practice to keep yourself refreshed. If not, you have to sort of relearn everything again for J2, and you don't have much time, right? And it might be a daunting task. But one thing I didn't do, which I regretted, so this is also a learning point for all of you who intend to do further math. Take this December holidays, next year, 1 year later, to relearn some of the topics or relearn some of the chapters that you have been struggling with throughout J1, all right? Because now you have nothing else to take care of in terms of academically, other than the wonderful project work. And you can just keep your mind to just drilling this subject, getting rid of this topic. And you really realize that it's actually very helpful. But I didn't, right? I left that to a later time. But whatever it is, it was still meaningful and fruitful. Now we came to J2, block test 1. We learned the 2 remaining pure topics, differential equations and complex numbers. Again, just a disclaimer, some schools will plan their further math syllabus differently from my school, all right? Okay, learn the 2 topics. Okay, very good. Very easy. Nice. And I got back 52. I wasn't mad. I wasn't mad because I already knew that I was going to get that grade when I sat for the paper. But it was, a good reflection on my performance, because it's like, I thought I knew it. Apparently not. So that is the journey of further math, right? You think you know it, but haha, put a sneaky on you with just a context change. And that is a volatility of further math, right? If you cannot do the volatility of further math, then you don't need to take further math already. But don't worry, you will develop the skills and experience you need. Just that it's gonna be painful at times and very seldomly good at times on the earlier stages. Okay, so this 52, okay lah, 52 52 law, what you want to do, right? Just learn lah. Keep your head down, continue learning, continue putting the effort. All right, nothing to lose. Okay, then now at this point that I started learning linear algebra properly, right? It was 1 hour of me assuming 2 roles, myself and me, right? One as a teacher, one as a student, and it was 1 hour of just pure insanity, right? And it was amazing, right? Although my mom came in like halfway and asked me if I need to, get myself checked, but no, I mean technically yes when you take further math, but whatever. Came the block test 2. The prep for block test 2, which I'll touch on very briefly later on, it was very smooth sailing, because once you get the idea, you get the groove going, it's very smooth, right? You really understand what they like to test, you get the techniques very fast. And I got a 70, which was surprising because the day before the exam, I slept from 12 to 2 a.m. I don't know why I had bad insomnia, but I'll take it, all right? It at least shows that my knowledge is sort of there. We just need to make that final push to prelims, work hard, keep our head down, just learn more, deal with the context, and we are good to go. Came to prelim prep, you realize that, hey, I should kind of come up with my own ways of learning, right? Or remembering things. And that is actually one of the very important solutions to further math, is to be able to come up with your own way of thinking and a way of adapting. And that was what the prelims paper taught me, and that's what I exhibited in my prelims. Paper 1, 85 out of 100, and a bit of a flop for paper 2 because I got 67 out of 100 because I think I was high during that paper. I don't know what I was doing. Looking back, it was a cringe. I made a lot of very bad mistakes, but it was an important lesson. All right. This important lesson was, it's not about not getting cocky. I wasn't cocky, right? I was still, trying to just maintain myself, maintain my pace, maintain my knowledge, focusing on the task at hand, which is just to do math and to think straight. The lesson is, do not pressure yourself. And that was what happened in paper 2. Right? I pressured myself, I started overthinking, and basically couldn't experiment in a more effective way or efficient way. Right? And that was basically the downfall of paper 2. So good thing is my knowledge is there. Bad thing is, or something that needs to be worked on, is just my exam techniques. So I focus on that from prelims to A's, and that's where the story ends. And if you guys are wondering what happened in A's, it was a 3-hour paper, right? For each paper was 3 hours. I took 2 hours for each paper and ended up getting an A. All right. Although it'll be really funny if I actually didn't get an A because I finished everything in 2 hours, which means I did everything badly. So this journey, ups and downs, but it's really meaningful. And it was mind-blowing. All right, you get to learn a lot of techniques, a lot of ideas, a lot of ways to think, right? A lot of ways of new ways of analyzing things, a lot of new ways to breaking it down, and more importantly, the lesson I learned for further math that's also transferable to the other subjects is to create your own way of thinking, right? No matter how stupid it sounds, no matter how lame it sounds, as long as it worked for you, you can't argue against grades. Okay? So, exam prep. Now, the good thing about further math for exam prep is that once you take further math, is basically combining both math and further math and converting it to 1.5, right? It's a 1.5 subject because the skills in math you need for further math, the further math skills you gain would help you more in math as well, right? So you will actually benefit a lot in terms of your practices, in terms of your studies, or in terms of your time management for your JC life, all right? So that is also a good point to take note of. And I don't know why the animation, okay, fine. And I've been talking about the novelty in further math, right? There are no question types, many unpredictable questions, right? But they're not that unpredictable to the point that you cannot do, right? Ultimately, further math testers test your fundamental ideas and your mathematical thinking. With that, that's your ammunition. Your trigger is your ability to analyze, observe the context, try to sieve out what clues and what hints are they giving you. And lastly, the important thing that's not just unique to further math, applicable to the other subjects as well, is your ability to experiment logically with your ideas, right? You will end up getting somewhere, right? Every incorrect answer in the further math is a learning point for you. Every failed experiment during the exam would ultimately lead you to the right method because you don't need to have all the methods available, right? You just need the methods that you are taught in further math. All right, and of course, with it, the logic, the very basic logical thinking, and the mathematical steps. Now, conclusion. All right, before the taster course, very short one. For the math, you need the ideas, you need the ability to experiment, you need critical thinking, and you need personalized thinking, right? These are the 4 tips I will share that you guys should have during your further math journey, all right? And to make it easier for you guys, I'm sharing them now. And along with those 4 skills that you gain in terms of your personality and your character, it really helps a lot, right? So that's why further math is a journey, not for your mind, but for your soul as well. And as mentioned, the habits and skills transferable between each subject, and you come out as a more mature person, as a further math student. Some advice for you guys: keep your head down and learn, right? That's your only goal in further math, right? It's a daunting task. Learn the techniques, learn the tricks, and you can outwit further math. Work with your classmates, right? Some of them are very smart, right? My batch had some amazing mathematical thinkers. I learned from them and also engage in discussion, and it will help you with your understanding and your techniques. And most importantly, I think that is not really said explicitly is that don't worry about struggling, right? Don't worry about making mistakes, right? Now is your prime time to make mistakes, right? Because now then you will learn and you can apply them in the future. And that is the whole essence of further math, is about making these mistakes, struggling throughout the fun parts, and at the end just laughing at the questions and wondering why they even bothered to test you. Okay, I think this was a very good advice for my coach a few years back, all right, 5 years back. You can react to your mistakes, but always don't forget to respond to your mistakes. What do you learn and what you can do? Okay? Now, final advice. What's the final advice? I think it's in general, whether you are taking further math or not, to every JC student out there, it's okay to set goals, right? But the same goals you set now may not be the same set of goals you want in a year's time, in 2 years' time, in 3 years' time, in 4 years' time. The things that you like now may not be the things that you like in 1 year's time, 2 years' time, 3 years' time, 4 years' time. All right? So don't be afraid to change your goals based on your experience. All right? Your experience will guide your heart, and your heart will guide your goals, and then you can derive meaning from it. All right? So when you choose your combinations, be it further math or not, think of what you like currently, but have that open mind that, hey, things may not go out so well, what's my other plan? Or keep an open mind that, hey, you know what, it might go well, I might start enjoying it, let's just give it a shot, regardless of outcome. All right, so that is my final advice to all of you who wants to take further math. Now, if you recall from the first few slides, mathematical induction is one of the ideas or one of the things that you'll learn in further math. Okay, what's mathematical induction? So this is a bit of a sample lesson. It's a type of proof for a statement for natural numbers. Now in H2 math and further math, you'll be looking at a lot of these symbols. And this is the symbol for natural numbers. The one for real numbers is looks like R, right? So okay, just a caveat, right? You don't have to draw it exactly like it. This is H2 further math, not H3R. Okay. Now what are natural numbers? 0, 1, 2, 3, basically any countable number plus 0. And it's essentially a type of proof for a statement, okay, or a proposition. And that is true for all defined natural numbers. So what do you mean by defined natural numbers? If we define the statement to be n bigger than or equals to 1, then you just need to prove that it is true for 1, 2, 3, on all the way to n. All right, two types of induction, soft and strong. In the H3 syllabus and further math syllabus, it is the soft induction. So what does soft in mathematical induction does? It's something like a chain reaction, so something that looks like this. But in a more serious note, it looks something like this. 3 things you need to do. First thing, show that the first dominoes fall, right? Because the idea is that for the rest of the dominoes to fall, the first one needs to fall first, right? That is the logic. Now, this is where soft mathematical induction kind of gets its name. You, instead of showing that the K domino will fall, you show that the K domino is true, right? You just assume that it falls, right? Because now the idea is, when you assume that this domino falls, the next one should fall, right? Logically speaking, right? So we need to show that the next one falls under the assumption, right? So if this one actually falls under assumption, then the cave domino actually falls, right? Because this can only fall if this falls. If this doesn't fall, oh, then clearly this doesn't fall. So that is the whole idea of mathematical induction, right? You assume that the cave domino will fall and try to show that the next domino, k plus 1 domino, will fall. All right? So let's start with an example, and I'll go through the presentation required, right? This is one of the few topics that require a lot of English. Prove by mathematical induction that the sigma, and this is basically the Greek symbol, capital S, sigma, basically means a summation of r squared from r equals to 1 to n. So essentially, this means that you have 1 square plus 2 square plus all the way to n square. All right? That this is true for all positive integers n. So integers, aka 1, 2, 3, 4, 5, basically any whole number, right? Negative or positive. But because we only want the positive integers, it will be 1, 2, 3, and so on and so forth. So how do we do it, right? So back to the idea. First, we let this be a statement. Let Pn be the statement that right? Some more symbols. This upside down A for all. Right? You don't have to use these symbols, you can write out in words, but for saving time, we like to use a lot of symbols. N is n, the variable. This sign is called the element of. Right, so it is part of or element of z integers. Z is superscript 1, superscript plus positive integer. Okay, so that is how it works. All right, so essentially when I read it out is da 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 for all positive integers of n. Back to the idea, what's the first thing we need to show? First step false, n equals to 1 false. Left hand side equals to right hand side. So what we do? Very simple. Substitute n equals to 1. So n equals to 1 is just 1 square, right? 1 square is just 1. So left hand side is 1. Right hand side, you substitute everything with 1. So 1 over 6 times 1 times 2 times 3, 1 over 6 times 6, 1 as well. So we now know that left hand side equals right hand side. The first domino is true and it falls. Next step, we assume that the kth domino is true. Right, so assume that pk is true for some k positive integer k. Why do you say for some? Because not all, because we haven't proved that all k would fall, right? So we just assume that maybe some k will fall, some k wouldn't. All right. And the text in green is something that you need not write, right? The text in yellow is the things that you need to write. The text in green, you don't need, right? So when we assume that this is true, we assume that this statement is true for k. After we need to show that the next domino falls, the k plus 1 domino fall. Okay, so we need to prove that basically the same equation as above here, but with n equals to k plus 1. So what do we just do? Right, so the ideal mathematical induction is that when you're proving the next step, you would then use the information from the assumption, aka use this information here. All right, so as you can see, I break the summation, right? I sum from the one, I want to sum from the first r equals to 1 to the k plus 1, right? The first term to the k plus 1 term. So I break it to summing from the first term to the kth term and adding the k plus 1 term manually. Then what I do is, you notice that here is basically here. So I just put that in and then do some factorization and simplification. And then I get what I need to show, which is down here. And this is the right-hand side that I'm talking about. Okay, so that is mathematical induction. All right, to conclude, since P1 is true and PK is true, because PK plus 1 is true, by mathematical induction, Pn is true for all positive integers of n. Okay, so 3 steps again, right? First domino falls, assume that PK is true and the big 2 words for some, and then you just need to prove that k plus 1 is true using the assumption, right? So this is what I meant by you need to incorporate the assumption. Okay, there's another example, but I won't be going through because I'd like to answer some questions, but you can download the slides and try them out yourselves. And I will actually leave you with these 2 questions because when I talk about creativity and freedom of expressions, these 2 questions I'm talking about, right? These 2 questions require you to have some freedom and creativity of expression. Now moving on to the Q&A. First question I was asked, do I get some difficulty in studying further math, right? What's the benefit of learning further math? Right, what is the workload? For math, I like to put it quite, generally, it's just another math subject, right? Higher knowledge retention, personally, and it's more efficient when it comes to me studying it. Now, although the main problem is the difficulty because of the context, all right? And in terms of workload, it is a tutorial system, right? It's more discursive rather than, hey, why never do this question, huh? Hey, where's your homework? It's not, right? You go to tutorial, maybe have attempted some questions, but not fully. And you go to bring to class, bring to tutorial to just discuss with your teachers. So it's more specific type of learning. All right, so this is the tutorial system. All right, now moving on to the questions. It's kind of a rush. I apologize because I realize I'm running out of time. If math easier than further math, definitely. All right, it goes without saying. Okay, further math, a lot more volatile, as I mentioned just now, than that. Should I take H3 math or H2 further math? Okay, H3, any H3 subject is an add-on, all right? So you cannot take H3 Math to replace a H2 subject, okay? So if you want to take H3 Math, go ahead. You can take it with or without further math, right? H3 Math is just an add-on, right? It's just like a DLC, okay? So it's more of like an enrichment kind of thing, right? That's the whole idea of H3. Is the standard of further math comparable to that of SMM Open? I like to proudly say that I have no experience in Math Olympiad at all, right? Not even from primary school, not even secondary school, not even in JC, right? So I can't say that, but I have looked at the questions. SMO Open is a little bit more difficult, and it has their own own type of skills and techniques you need for for SMM Open, just as it is for further math, right? Further math has their own set of skills and techniques that's unique to further math as well. HE math versus FM. All right. So tomorrow there's a sharing on O-level math versus H2 versus FM versus H3. So that is what you might look forward to and you should attend. What do I mean by techniques? Differentiation skills, integration skills, basic mathematical techniques. In terms of thinking, critical thinking, are you able to sieve out the information? Are you able to, most importantly, translate that information to mathematical ideas and mathematical terms? Then that is what I mean by techniques and thinking. Okay. So personally, for me, techniques, you should try to find your own pattern, right? It's just, and you build a lot of familiarity with some of the techniques as well. You can kind of really like preempt or already can predict what is to come, right? What's the next few steps, and then voila, it's an easy 5 marks. Okay, so it's more contextual for the math as compared to H2 math. It's just more theory. From what I know about H3 math, again, I never took H3 math because I don't want too much on my plate. But I've self-studied H3 math. It covers a very different side of math, right? H3 math covers the more theoretical stuff like number theory, bringing calculus, and more of like the more abstract kind of things. For the math, at least, it's a mix of abstract and a bit of application as well, right? So such as definite integrals, we look at finding the volume and stuff. In retrospect, would you have chosen 2 signs of FM in terms of difficulty and passion? For me, because I can't do physics, and I completely gave up on bio after Sec 2, and I already knew I wanted to do further math in Sec 4, right? In mid-Sec 4, I already knew I wanted to do further math. So I was going to do further math anyways, because for back then, I know that I can cope with further math way better than coping with physics, way better than bio. All right. And also back then, I already had the idea of doing passion. I already knew that I want to do math and chem because I was doing well in those subjects. Also, probably because I like those 2 subjects as well. How do they teach FM in J1 without finishing H2 my background? They will arrange the syllabus in a way where the both topics will coexist, right? So, for example, if they're going through sequence and series, they'll be going through recurrence relations, all right? I mean, although they are not, you don't need some topics in further math, you don't really need skills from H2, like numerical methods, right? Numerical methods are basically approximations. It's just key in calculator. If they're nice, they let you key in calculator. If they're not, they introduce some constant and you have to do it manually. That's also the reason. That's also the tedious part of further math that can be really annoying. Well, give you an example. Imagine doing the entire stats paper and all questions have a constant, unknown constant like alphabet. And you're like, why do I even bring a calculator for further math for the stats paper? All right. Yeah, so they would arrange the concepts together. So let's say if they're teaching complex numbers in J1, they will also be teaching complex numbers during the time or after that time. All right. Yeah. So don't worry about the allocation of topics. I mean, logically speaking, they would do that. I don't think they would like, oh, come, you are still in sequence series, come, let's just show you differential equations. Why? Why? Why would you do that, right? So don't worry, trust your syllabus. If you want to, you should check with the schools that you like to attend, right? Every school teaches their syllabus differently and the way they arrange their syllabus, not just for further math, but for H2 as well. Yeah, hope that helps. Yeah, so for those of you who wants to know more history, right, attend the talk tomorrow. I can't remember what time it is, but it's basically as a comparison between the formats, right? From O levels to versus H2, further math, and H3. Yeah. But regarding the SMO question, I think maybe I'll have to just touch on that a little bit more. If you have done SMO open in secondary school, yeah, I think you should be able to understand further math. What careers can we take with FM and math? What career are you planning? Which uni am I going? I won't disclose what uni I'm going. FM, you're looking at the courses that I mentioned earlier, right? Computer science, further math, no, computer science, math, engineering, data science, right? So, which can be relevant, right? We talk about like statistics and the idea of technology and data. So for me personally, well, reason why I'm here also is because I aspire to be an educator. If I still want to be an educator, like after I go to uni, or my perspective change. So I have a few options in terms of career. My main one is education. Something else maybe like going to some pharmaceutical company to help with their statistics or with their testing and stuff. Yes. All right, so I will have to end here.